So this video is on how to make and identify genotypes from a pedigree analysis. So a pedigree is basically a family tree. And so it starts out with basically a female being a circle and a male being a square. A line between the two of them indicates a mating. We drop a line down from that for their offspring. And siblings are going to be connected by a line above them. So here I have a set of parents with 3 children, 2 daughters and 1 son. Then we can add in, let's say the son gets married and has a daughter. This daughter gets married and she has, let's say, 2 sons. And we'll just say this daughter over here, she didn't get married. She didn't have any offspring. So from here, this is just a very basic pedigree, basic family tree. Now, so far we haven't identified any trait or anything else that's in it. So let's say then that the son here, he is affected by trait T. And we're not going to identify what trait that is at this point, but we're just going to call it trait T. Now, he has it, as does one of his sisters, her, as do both of his nephews, right, and his mother has it. Right? Nobody else in the family tree has this trait. So the individuals who are filled in, who are shaded, they have the trait. They're what we call affected by the trait. And everybody who's not filled in is not affected. They don't show this trait. So colored in versus non-colored in, that's the phenotype. They express it or they don't express it. What we need to determine then, first off, is the trait dominant or is it recessive? And then once we've determined if it's dominant or recessive, then we can determine everybody's genotypes. And the key for determining if a trait is dominant or recessive has to do with whether it skips a generation or not. So when we say skips a generation, what we mean is that we have 2 parents that are not affected, neither of these 2 are colored in, having a child that is affected. Okay, that is skipping a generation. Okay, and that's going to tell us that the trait is recessive. Okay, and that can be anywhere on the chart at all. It can be to the left, to the right, to the top, to the bottom, and it doesn't have to skip a full what we think of as a generation. So it wouldn't need to skip this whole line. It just skips right here. So this, for this particular trait, for our trait T, this tells us that this trait is recessive because it skips a generation right here. We have our 2 parents that are not affected having a child or more than 1 child that is affected. Now they could also have another child that isn't affected. That doesn't matter. So long as we have 2 parents not affected having at least 1 child that is affected. So now we know that this trait is recessive. That's then going to tell us that anybody who's not colored in, whether they're male or female, they're going to have a big letter and a big letter or a big letter and a little letter. Okay? And that anybody who's colored in, again, whether they're male or female, they're going to be 2 littles. That's going to be their genotype. Okay? And I like to make myself this little key each time I do a pedigree just to help me remember as I'm going through the chart what everybody should look like. So I like to start by identifying the genotypes of everybody who is recessive because we know they're always going to look the same. So in this chart, since the trait itself is recessive, then we know that colored in is recessive. So everybody who's colored in, I'm going to give them 2 little t's. Okay, so I'm just going to go through and everybody who's colored in gets 2 littles. Okay. Now everybody who's not colored in, they're going to get at least 1 big. Now I don't know for sure if they're going to have 1 big and 1 little or 2 bigs at this point. So I'm just going to go through and give everybody 1 big letter. Then I'm going to go ahead and start working on their second letter. So I like to work from the bottom up, but you can work either way. So we'll do this one from the bottom up. We'll do the next one from the top down. So here, I know that this girl's second letter has to be a little t because dad only has little t's to give. So dad's going to give her a little t, whereas mom gave the big T. Now, because mom here, she married in, we don't know what her other letter is. We don't have her parents to get it from. So we're going to put a question mark there. So leaving a question mark is perfectly fine if you don't know what that other letter is, if you have no way to figure it out. Now, if they had a second child who was homozygous recessive, then we would be able to figure it out. So let's go ahead and go over here. And we have a child that is homozygous recessive, and both parents are dominant. So in order for them to give birth to this child, they both have to have a little letter. Now, when we have these two parents that are both heterozygous, and they have a child that's dominant, we have no idea what that other letter is. It could be a little t, or it could be a big T. So again, we're going to actually call that big T question mark. We have to leave the big T because we know they have at least one big, they're not colored in, but we don't know what the other letter is. We would need their offspring in order to identify that other letter. So we only have one person left here, and that's Grandpa at the top. Now, Grandpa, in order to have given birth to this daughter or this son, he has to have a little letter. So he's going to be big T, little t. So fairly straightforward as we go through our chart. Now, let's go ahead and run through a dominant chart, what a dominant chart looks like. So let me find that one for you here. So this is a dominant chart, and I can tell that because I don't have anywhere where I have two parents that are both non-colored in having a child that is. So because I don't have that anywhere on this chart, I know this chart is dominant. Okay? And because it's dominant, anybody who's colored in is going to be big D, or big D, little d. And I'm just using D's because I don't have a specific trait for this one. You can use any letter. It doesn't really matter. I just recommend using letters that look distinctly different, uppercase versus lowercase. So then my non-colored in, I know they're going to be a little. And so I'm going to go ahead and start again with my homozygous recessives. So I'm going to give all of them their two little d's all the way across the chart. And then as soon as I'm done with that, I'm going to go ahead and give all of my dominants their one big letter. So give them all a single large uppercase D here. Okay. And then once I'm done with that, I will go ahead and start filling in all the individuals. So I'm going to go ahead and start at the top this time just to be different. So looking for her other letter. Now I have to make sure I'm only looking at her children. So I've got this guy, or I'm sorry, this girl, this guy, this girl, and this guy. Now they're all big D's. So she could have given the same allele all 4 times. So I'm going to go ahead and give her a question mark, even though I know most likely she's actually got a second big D there because all of her children are dominant. But let's go ahead and go down and look here. So here, now her dad has to give her a letter, so he's going to give her a lowercase d. And then for all these kids down here, we're going to have the same thing. Mom's going to give her big D, dad has to give a little one because that's all dad can give. So I'm going to give all of them their little d's from their dad. Now for this gentleman here, this guy, again, he gets a little d from his dad, got his big D from his mom. Over here, again, we've got a little d coming from dad. Now again, same thing here, we've got 3 kids, all dominant. They got their dominant from their mom. Their dad only has littles, so he's going to give a recessive to each of those kids. And then as we come over here, we have children that are recessive, so they had to get a recessive from dad, so he's going to have a little d. So again, this is a dominant trait because it doesn't skip a generation anywhere, and we're able to fill out just about everyone except Grandma up here. And we could give her a big D because all of her children have that big D. But you got to be careful about that because if you look at this one, she's got 4 offspring that have that are dominant as well, but she has 1 recessive. So we do need to be careful making that assumption. The last trait I want to look at is a sex-linked trait. So this is a sex-linked, or again an X-linked. So we need to remember that when we're doing these, our notations are different. We have our XY, we have our X, let's say H, we'll call this one hemophilia Y. We have XX, XHX, and XHXH. So our only two affecteds are going to be this individual and this individual, right? Whereas this person here, our heterozygous female, she's going to be a carrier. So she's going to look like this down here. Now, since this is a sex-linked trait, we know that everybody who's colored in is affected, and everybody who's not colored in is not affected. The carriers are marked with the half circle. Sometimes instead of a half circle, you'll see it marked with a dot, or that they'll be shaded in a different color. So we can go ahead and fill in this chart pretty easily, I think. Everybody who's male and not affected, they're going to get a normal XY. So we can kind of start there. Give all of our normal males XYs and all of our normal females XXs, because they don't have any alleles either, any affected alleles, sorry. So XY, XY there, another unaffected male, another unaffected male, and an unaffected female. So then all of our affected males, they're going to be all of our shaded in males. So we're going to give them XHY, XHY for all of our affected males. Let's go ahead and fill all of them in here. XHY, and one more at the top, XHY. Okay. Which leaves us simply with our carriers, and those are going to be our XHXs. So we can go ahead and fill those in, and then we're done. Except we've got this one girl right here. We actually do have an affected female, so she's going to be XHXH. She's our one affected female. So you can see from this chart, I'm just going to go ahead and finish filling them in, but you can see from this chart how rare females being affected with a sex-linked trait is. In order for a female to be affected, she has to have an affected X coming from dad, which means dad over here has to be affected with the trait, and mom has to be a carrier. So it's very difficult for females to be affected with sex-linked traits. So at this point, you're going to go ahead and look at the pedigrees in your book, fill those out, and let me know if you have any questions.